All right, it's that time again. Let's talk about batteries. All right, this time around, we're gonna be talking about our line of lithium iron phosphate batteries that we have at Jack 35s. You know, we've been selling all kinds of batteries, and these are the latest. Everybody wants these because they're safe and they're long lasting. And it'd been a while since we could get any in our hands, but now we got a large load of these. And so now we are putting them out. But I've been lagging, or it might seem to you guys that I've been lagging on coming out with the finalized versions of these, right? Because, well, it's been a month or maybe a month and a half since we started selling them, and the BMS haven't materialized. But the reason for that is because I've been working really hard, trying a bunch of different things and failing at coming with the right product that I want to put out there, right? So what kind of problems we got, you might ask? Okay, so I'll give an example. The problem is that I'm having to design these boards to go on top, right? Because these didn't come with that. They come in a different shape. These are recycled second life batteries, right? But they still have plenty, like they have 20 years of life, 15 years minimum, right? And so what I have to done is measure all these and then come up with the design of this board. But then the boards, the first version that I came up with, didn't like it because they were getting hot at like 100 amps, you know, loads and stuff. And these batteries are 8123 cells, and they can push quite a bit of power. So there's a lot of people out there that might want to load these up with like 100 amps, right? And so if you want to do that, the earlier versions are like can't put that much power, right? And I've been testing this stuff in the thermal camera, and it's like nope. And so then what I've been having to do is put like a bunch of things. Like we tried doing like putting wires in there like extra so that they can carry more amps and stuff, but that'll just look chintzy, and it just didn't look the right way. It worked, except that it added sometimes like some issues. Like it was working for the time being, but long term, I knew that I was gonna have to come up with something better. So then I kept trying. Finally, we came to a board design that uses two levels, two layers of board. Because this is cheaper. You know, I know what you can say, why didn't just go to like thicker copper, like 2 ounce. But 2 ounce more than doubles the cost of the boards, where this only adds a tiny bit more because now it's a smaller board that you put on top, but it serves basically, now this is a 2 ounce copper traces on this board, but without the cost of doing that, you know. And it took a few tries and stuff. And basically what it's going to end up being for the final version with the BMS on this is going to be 4 different board designs, because here's one, the blue one, and then here's the black one, right, which reinforces the thing is the secondary line. And on the BMS is the same thing. And the reason why I came up with this design is because I've been trying to get the BMS to be able to output 200 amps, for example, on this one and on this one. And the traces are really small, right? This one is a cutout design because I didn't want to have to use too many of these standoffs, which are expensive. And so in order to keep it cheap, then I had to cut a hole in this design and put them in there. But then the traces are very small. So to carry 200 amps, you have to get creative. And that's how I came up with that design of adding a secondary thing, right? And so now that's trickling down to all of these batteries. And a month ago, we only had the 12 volt versions, the 50 amp, the 100 amp, and now we've introduced the 24 volt 50 amp, right? For those people that are going to use 24 volt systems. So there we go. That's the long story of why it's been taking so long. I've been trying. I've been working really hard behind the scenes. You guys might not have seen that, and maybe that's if you notice that I haven't been putting out videos, this is the reason why, because I've been working on this really hard. This is just, 1, 2, 3, 4, 5, 6 projects, but I also have the other project over there. I have this project over here. There's a bunch of projects that are going on, and we're now getting to the point where we're going to release them. So today I'm going to talk about the BMS, but because not all of them are ready, the 50 ampere is ready. This one is not ready. I'm waiting for the finalized boards. This one is ready, right? I'm going to take one of these and talk about this one in this video, and then I'm going to make a separate video about the other ones to go into very detail. But let's do the 12 volt 50 amp version first, because that is the cheapest one, the most affordable battery that we have in our lineup, and that is one of the most popular. So let me clear the table here, and then we'll go and talk a little bit about that. All right, so this is our lithium iron phosphate 50 amp 12 volt battery, right? Very, very popular. It's $99 on our store, which is about half the price of what is commercially available out there. Now, it's just a battery. It didn't have the BMS, but we added a link to a very popular 100 amp BMS that you can get, and Amazon or AliExpress and all this other stuff, right? So people have been asking us how they can easily install this BMS, and the answer was like, well, you just connect the stuff. You find a connector that goes in there. These are the info on these are out there. It's just a IDC connector. This one has 16 pins. They're different, all kinds of pins, and then you connect it in there. For example, this one. All right, so this one, you basically use the same cables that we've been using on all our other systems, and then you can test and see the cell voltage using this battery Go BG-8S. The answer is like, is there an easy way? There wasn't. You just have to kind of connect and get a connector and configure stuff. But eventually, I just made the board, and this is the board that goes on top, and now you can populate it with this 100 amp BMS that you can find. And I put the address here on stuff to make it easy for you people to buy this. I'm gonna make this available at PCBWay.com. PCBWay.com is our sponsored, and they have an online store where I can submit the designs, and then it becomes open source, and you guys could just go and download as many as you want of these and populate them yourself and save money by doing it yourself, right? Eventually, down the line, maybe we'll offer this on our store. We'll order a bunch of them. We'll populate them. Have our guys in-house here populate. But for right now, this is how this is going to be. You're going to have to get the cables. Click on the links and get the cables, right? So the way you mount this is by using standoffs. These are M5 standoffs, which are the same size of screwed studs that are on these batteries, right? And so what you do is you take off the corners, basically. So this one, and that one. This one's loose already. And then these ones, you'll have to loosen them up. There we go. Put these in here. Tighten them. By the way, this is the 8th iteration of this board. That's how many tries it's taken me to get it where I'm happy with it, right? And so you got some earlier iterations. It works. It's just I wasn't 100% happy with it. Then after you do that, now you put this connector. You're gonna have to get this little connectors, just a, again, 16 pin IDC connectors with a 16 pin ribbon. And then you put this in here, which now connects to the cell balance leads of the batteries, right? And then that's what your BMS here is gonna need. So then you put this board on top. Now you notice that these are hitting here. So what I'm gonna do on the final version of this board, I painted it here just to add another layer of safety, because it is touching those connectors, right? But there is well, what is that? That's the positive. Yeah, that's the positive lead that is gonna go in there. So in order for it to not, now if you're populating these boards yourself, I guess what you can do is not put these connectors, because then these are gonna be just so that you can use them if you're not using the BMS that is like this, that you're gonna use a centralized BMS, put a bunch of these together, connect them all together, and then have a BMS in a separate place, right? But if you're just gonna use them individually, then this is the way you would do it. So then what you do is now you put screws on here. And then you should be able to connect this guy in here. And that is it. Now you have a BMS on this battery. This is the charging port. This BMS just happens to be one that has 2 ports, one for charging, one for discharging. So you can connect your charger in here and then your discharger in here. And so this is rated at 100 amps, but obviously, you know, these can do 60 amps or something like that. Wait, the 90s, yeah, 45 amps each. So together, the power output will be like 75 amps if you're using both of the XT90s. And so that's what you are limited at. If you need more than that, then you'd have to go with a more centralized BMS. Put more of these batteries in parallel and then use a bigger system, right? And by that, if you're doing that, then you might be more interested in the 100 amp hour 12 volt battery that we have. It's easier to make bigger systems, right? This one's, you can do one like this or a couple like this with the own BMS, and then they'll work together and they'll make a 100 amp hour, 150, 200 amp hour battery. But if you're going to go bigger and you want one BMS, then maybe the other way. So there's options to go with these. And sometimes options get a little bit confusing, but I'm trying to find that happy medium where I give you options to build batteries many different ways, but also make it simple so that, you know, people that are not too experienced or they're new into the battery world can tackle these projects on their own. So anyways, this is what it's finally gonna look like. And this is now a 100 amp hour, no, a 50 amp hour, 12 volt battery that has a capacity of 75 amp through these connectors, and it's got its integrated BMS, right? So this should be safe for you to charge, discharge. The BMS should stop if the cells are out of balance. The BMS should stop if once the cells get too low, or if you're charging them and they get too high, the BMS should step in and also disconnect the battery so it doesn't overcharge and you damage the battery, right? So there you go. This is the 12 volt battery BMS. This is open source. I will give you the links where you can go and download and order the boards and links to all the connectors and the cables and the ribbon and stuff so that you can build and solder this yourself and make this battery. All right, I want to thank PCBWay for sponsoring this video, and we'll see you guys on the next one. Bye.